Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily lead code problem, and the problem's name is delete leaves with a given value. You will be given a binary tree root and an integer value target. Okay, and there will be some leaf nodes of the given binary tree. You have to delete all the leaf nodes with the target value. Okay, and there is a further add on to the problem that note that once you delete the leaf node with value target, and if by as the result of that deletion its parent become a leaf node, it means that let's suppose that there is a situation in which, let's say, the target value is 2. Okay, and this is the tree which is given to us, 1 and then 3 and then 2, and then let's say it's 2 and 2. Okay, so this is the tree that is given to us, this is the root. Okay, so you have to perform this kind of deletion on the leaves, so you will delete the leaves first. So target value and leaves value are matching in these two, so these will be gone. Okay, now what about their parent? It have also become a leaf node as a result of the deletion that just been done of these two left and right childs of this particular parent. So it become a leaf node and its value also happens to be equal to target value. So if these two conditions are satisfying, then you will delete this node also. Okay, this is what the meaning of this add-on. Note that once you delete a leaf node with a value target, if its parent node becomes a leaf node and has value equal to the target, it should also be deleted. Okay, you need to continue doing this until you cannot. Okay, you will keep performing this operation until you cannot do so. So this is what we have to do, and let's have a quick look at the constraints also before thinking of an approach. So according to the constraints, the value of nodes, the number of nodes in the tree will be in the range 1 to 3000, and node value and target value will be ranging from 1 to 1000. Okay, so these are the constraints. Let's quickly think of an approach. A very intuitive approach which is coming to my mind is we can do the thing that we just did. We will somehow reach at the nodes, leaf nodes first. Okay, and then proceed with their deletion, and then we can you know do this thing recursively while checking whether after making some deletions a node have become a leaf node or not, and if that node is values is equal to the target, then that should also be deleted. So a DFS will be very suited approach for this one. Those of you who are hearing the word DFS or this approach for the very first time and are not familiar with it, I will try to find an article on DFS which will be explaining what DFS is, how and when to use it. Okay, so a link will be provided in the video solutions description. And in nutshell, what I can tell you about DFS is you start from a point and you go down a certain choice path. So there are some choices of paths. Let's say I decide to pick this one. Okay, then again after this point, let's say you have some more choices, then let's say I decide to pick this one. Okay, so so on you will keep making the choices. Okay, and there will be a point where you cannot proceed further. There will be no choices beyond that. So after exploring this to the very end, Okay, so that's why depth first search. We are going in depth first. Okay, till the very end. Then coming one step back and if checking if there are any other choices left unexplored. So we will do that. And this thing will, repeat. So this is what DFS is in nutshell. Anyways, please check this link out if you are not, familiar with DFS. It will be very helpful to you, and proceeding further in the solution also you will able to understand it more clearly. So without further delay, let's quickly take the code to the slide and have a discussion on the implementation, how we have implemented this approach programmatically. So let me quickly take another slide. Yeah, this is the, you know code that we will be discussing. So let's copy one of these images. I think this should be fine. Yeah, so what we have done here is, firstly we are checking whether we are at a, no null node. In it will happen in case like this, when you will be at a leaf node and you will be making call to this remove leaf node function, then these will be null. In that case you will be returning null. Okay, so this will return null and this will also return null. Okay, so why we are returning null values? It is to identify whether a node that we are currently visiting is leaf node or not. How we will identify that? By this particular if statement. Firstly we will make recursive calls for left and right child of the current parent, or root you can say. So root's left child, root's right child, and recursive calls for both of them. They will return us the value or the address of, or the reference you can say, of the nodes. Okay, either it will be a null value or it will be some actual address of a node. So once we have those addresses or references you can say of left and right subtrees that will be for the current node, then we will make the linkings. Okay, so it is something like this. Let's say when you made a call, let's say this is the right subtree and there might have been some deletions in right subtree. Okay, it might have been the case that, let's say these were 2 and let's say this was 3 and target value was 2. So this entire right subtree would have been gone. Okay, we do not know for sure. Right now what is the situation is, when you made okay, this is a left subtree, pardon please, and when you made this call for recursive call for left subtree, this was the link that help you made that call. Okay, so now let's say this entire left subtree is gone. Okay, but 3 is still connected to 2. Okay, you have to somehow change this link in order to reflect those deletions in your final resulting tree. Okay, so this is a very crucial step here. We are changing the links. Okay, or updating the links you can say. These two are updating the links. So what we will be doing is, let's say this entire thing is gone, and in changing or updating the link, this new link will be formed and it will be pointing to null. Or more specifically you can say that whatever is stored in this left node. Okay, similar thing you will be doing for right subtree, just like that. And yeah, once you have done the link updation and everything, then you will have a clearer picture or the of the current scenario. Okay, let's say this 3 would also have been 2. Okay, this is also a possibility. And let's say this entire thing would have also been gone. So in that case, your left node and right node both would have been null, and this 2 would have become a leaf node in that case. And what was the other condition that was required for deletion of this newly formed new node? That the value of this newly formed leaf node should be equal to the target. If that is being fulfilled, then you will return null. It means that you have also deleted this value. Okay, so that is that thing. And if these things are not satisfying, it means that this node will stay. Let's say it would have been 3, so this will stay. In that case, you will return root. Okay, so it's very simple, just a recursive function, and this is how things will proceed. And as far as we talk about complexities of this approach, time complexity wise, if there are n nodes, then we will be visiting every node only once. Okay, so time complexity wise, it will be order of n. Okay, and space complexity wise, there might be a case that the given tree, the tree that will be given to you can be a skewed binary tree, means like this. So when you will make recursive call, the recursion stack will be spanning the entire size of the tree. Okay, so in worst case it can be order of n because of recursion call stack. Okay, so this is the whole time complexity thing, and space complexities. These will be the complexities. And if you still have any doubts or any queries in general, then you may ask them in the comment section. And I hope this problem solving session and this solution walkthrough added some value to your journey of owning your DSA skills. And until then, keep practicing and keep solving problems. I will see you in the next video. Thank you for watching.